MATLAB has the ability to create outstanding graphs, which can be extremely helpful when you're documenting your results. You can customize almost everything about graphs in MATLAB: the line styles, symbols, annotations, and labels. MATLAB makes it easy to create both 2- and 3-dimensional plots. It's also easy to create animations or movies in MATLAB. These can allow you to visualize mathematical functions as they change with time. I won't try to introduce you to all of MATLAB's capabilities in this video. My goal is to give you a reasonably good background in creating 2-dimensional plots and cover the basics that I think most people use MATLAB for. With this background, you should be able to use MATLAB's documentation to figure out how to use MATLAB's other graphical capabilities. When a plot command is executed, the resulting plot is displayed in a figure window. When we did our earlier simple example, the plot command created a figure window automatically. However, you can control the creation of the figure window yourself. When the plot command is executed, the plot's displayed in the currently active figure window. Any plot previously displayed in that window is replaced with the new plot. If there's no current figure window available, one is created and the plot's displayed in that new window. This is what was done in our earlier example. You can use the figure command to create a new figure window or activate an existing figure window. The command figure by itself creates a new figure window. Each figure window has a number. The command figure of n creates a figure with that number if it doesn't already exist, or activates an already existing figure with that number. You can remove the contents of a figure window or delete the window itself with the CLF and close commands. To remove the plot from the active figure window, type CLF and press enter. This results in a blank figure window. To close the window itself, type close and press enter. When I created the plot in our last video, I created an array of times using colon notation. So t equals, starting at 0, incrementing by 0.01, ending at 10. Then I created the function itself by typing y equals 3 times exp of negative t over 2 dot times cosine of 4 times t. To plot the values of y at the time point specified in t, I use the plot command, plot of t comma y. In this simplest form of the plot command, the first argument is a vector containing the points on the horizontal, or x-axis, and the second argument contains the points on the vertical, or y-axis. When I press the Enter key on my keyboard, the plot gets created in a figure window. If there aren't any open figure windows, the plot command creates one. If there are open figure windows, the plot command uses the currently active window, which is the last figure window that was used. Now I'll create another function and plot it. The new function is z equals 5 times t dot times exp of negative t. It uses the same time vector I used before. Now if I plot z by typing plot t comma z, I do get a plot of our new function, but my old plot's lost. MATLAB's plot command uses the currently active figure window, the one I created with my last plot command, to put the new plot in. If I want to create a separate figure window for my second plot, I can use the figure command. To create the new figure window, I type figure and press the Enter key on my keyboard. This opens a new figure window. Notice that this is figure number 2, as you can see in the title bar. MATLAB numbers figures consecutively, unless you tell it to do otherwise. The new figure is the active figure window, so to plot the original function, I type plot t comma y and press enter. Now I have 2 figure windows, each of which shows one of the functions I wanted to plot. I can create a figure with a particular number with the figure command by placing the figure number in parentheses after the figure command. For example, if I type figure of 5, a new figure window is opened named figure 5. This is now the active figure. I'll plot one of our original functions in this figure by typing plot t comma y. The contents of the active figure window can be cleared with the CLF command. Figure window number 5 is still there, but it's blank. To completely remove a particular figure window, the command is close. Just type close with the figure window you want to remove in parentheses. For example, close of 5 deletes window 5. The window is gone. Close by itself with no arguments closes the active figure window. Close all deletes all the figure windows. Next, I'll talk about customizing the way that data are displayed on the plot. There are 3 primary characteristics for data display: markers of the data points, the color of the line connecting the data points, and the type of line connecting the data points. I'll just give some example codes here. Complete lists of codes are available in the textbook or MATLAB's help files. Line colors are specified by a letter. For example, R creates a red line, G a green line, and K gives you a black line. Lines can be solid, dashed, dotted, or a dot-dash combination. A dotted line is specified by a colon and a dashed line by 2 hyphens. Data point markers are specified by a symbol. Some examples are S for a square and a lowercase o for a circle. The codes to specify markers and line styles are included in a string following the data set being plotted. For example, plot of x, y, quote, r colon s, end quote, plots the data in the y array as a function of the data in the x array. The data points are connected by a red dotted line, the r and colon codes, and the data points themselves are indicated by square markers. Additional styles can be set by using what are called name-value arguments. Line width, for example, sets the thickness of the line connecting the data points, and marker face color specifies the color on the marker face. Now I'll demonstrate use of some of these features in MATLAB. The 3 most basic options are the line type, the line color, and the symbol to display the data points. These can be specified as a string in the plot command. Strings in MATLAB are specified within single quotes. For example, if I want to change figure 1 to a red dotted line, first I'll make sure that figure 1 is active by typing figure of 1 at the command window and pressing enter. Now I'll type plot of t, z, single quote, r, colon, close single quotes, close parentheses. R is the code for red, and a colon is the code for a dotted line. If I decide to change the appearance of the data points along the line, I can add an additional letter to the command. For example, to put circles at the data points, I can use a lowercase o after the symbol representing the line appearance. So I type plot of t, z, quote, r, colon, o, quote, close parentheses. Now I've got little circles at all the points in the arrays sent to the plot command. To see a list of all the available options, type doc space line spec. The help page shows line specifiers, marker specifiers, and color specifiers. On any plot, we'll need to include labels that tell us what the horizontal and vertical axes correspond to. In this section, I'll talk a little bit about adding annotations to plots. Use the xlabel command to add a label to the horizontal axis. The syntax is the function xlabel, and the argument is a string containing the label that will be displayed on the x-axis. To add a label to the vertical axis, type ylabel and include the label that you want on the y-axis as a string in the argument. Finally, if you want a title at the top of your plot, use the title command. As with the xlabel and ylabel commands, the argument is a string that you want at the top of the plot. The command to add a label to the horizontal axis is xlabel. To use this, type xlabel and open parentheses, a string that you want to be displayed, and a close parentheses. To label the horizontal axis of our current figure as time in seconds, for example, type xlabel of, quote, time, sec, end quote, close parentheses, and press enter. The corresponding command to label the vertical axis is ylabel. Let's label our vertical axis as z. Type ylabel of z. A title can be put at the top of any figure with the title command. The function for the current figure was z equals t times e to the minus t. To put a descriptive title, I'll type title of, quote, t times exp of minus t, end quote, close parentheses. Now let's talk about putting multiple lines on a single plot. We've already seen that if we just apply the plot function a second time to the same active figure, the data get replaced. However, there are a couple of easy ways to get multiple sets of data on the same plot. If you have an existing plot on the active figure window, you can type hold on to hold the figure. Plot commands you execute after typing hold on will cause the data being plotted to be added to the existing figure rather than replacing the previous plot. Typing hold off releases the figure. Executing a plot command after typing hold off results in the new plot replacing the old data. Or you can plan all of the data you want on the figure ahead of time and use a single plot command. Just list the x and y data for each plot on the figure in pairs. For example, this syntax plots the data in the array y1 against the data in the array x1 and the data in the array y2 as a function of the data in the array x2 on the same plot. Finally, if you have multiple plots on the same figure, you can add a legend to the figure to identify the various plots. The command is legend, and its arguments are the labels for the different data sets in the order in which the data sets were added to the figure. This command, for example, added to the plot created by this command, would label the line specified by x1 and y1 as data 1, and the line specified by x2 and y2 as data 2. One way to create a figure with multiple lines on it is to start with an existing figure. Normally, if I try to add another plot to this figure, I lose the previous plot. But there's a hold command that keeps the previous data and adds new data to the plot. I'll show you an example of this with figure 2. To make sure figure 2 is my active figure, I'll type figure of 2 at the command prompt. To hold this figure, I type hold on at the command prompt. Now, if I use the plot command again, the previous version of the figure will be retained and the new plot added to it. For example, I'll type plot of t, z at the command prompt. Now we have both sets of data, y and z, on the same plot. To release the figure, type hold off. Now if I plot some data on the figure, the previous version's lost. For example, I'll type plot t, y to get my earlier figure back. If you plan ahead a bit, though, you can do the same process without using the hold command. Just add successive sets of data within the same plot command. To illustrate this, I'll first clear the current figure by typing CLF. Now I'll type plot of t, y, quote, k dash to get a solid black line, comma, t, z, quote, r colon to get an r dashed line for the z data. If there is more than one line on a plot, it's probably a good idea to add a legend to the plot so that we know what each set of data corresponds to. The command is legend followed by parentheses enclosing strings corresponding to the descriptions of each set of data on the plot. The strings in the parentheses are in the same order in which the data appears in the plot command. For example, type legend of first data set, comma, second data set. We get a legend on the figure with an example of the line style used to represent the data and a description of the data. Finally, let's summarize the basic plotting commands I've introduced in this video. This is a relatively general syntax for a plot command. I can plot multiple data sets by listing the data sets sequentially. After each data set, I can include line specifiers to define the line color, style, and data markers. So this plot command plots the data in array y1 as a function of the data in array x1 using the line and markers defined in the string line spec 1. Then, on the same figure, I plot the data in y2 as a function of the data in x2 using the line styles specified in line spec 2. I can do this for as many data sets as I want to put on the figure. After I've created the basic plot with the plot command, I can label axes using the X label and Y label commands and add a title using the title command. Finally, if there's more than one data set on the plot, I'll probably want to use the legend command to describe the different data points being presented. This video presented what are probably the most common MATLAB plotting options. In the next video, I'll talk about some slightly more advanced capabilities. For example, I'll present capabilities for putting multiple plots in a single figure window, some additional line specification options, and setting limits on axes. I'll also talk about some additional options for text that you can annotate plots with, adding Greek letters, italicizing text, superscripts and subscripts, and converting numerical values to text that you can add to your figure labels.